How to build a boat in 5 easy steps. Step number 1, don't. Hello everybody, I am Nick the Naval Architect. In my work at DMS, I have encountered many ambitious clients that want to build their own boat. I love that ambition and that optimism. It's a regular part of my job to interpret that raw ambition. I work with my clients to refine their goals and translate that initial dream of boat ownership into a set of technical definitions. After a while, I've discovered several repeated themes as clients consider DIY construction. So today, I want to share several steps of self-discovery that anyone should embark on before starting a boat construction project. Step number 1, training for yourself. Taking a ship to sea is equivalent to going into the wilderness, absent from any of the support of modern society. And safe enjoyment of that wilderness requires a crew that can anticipate the dangers. Your ability to survive is going to depend on preparation. And that preparation only comes with training and experience. You should first get experience handling large vessels. Invest in yourself first. Purchase training courses and learn how to safely pilot a large boat. Here in America, the organization that I personally know best is the American Sailing Association, and they offer several courses that would allow you to progress all the way from complete novice straight through to experienced chartering capabilities and beyond. It's not just about improving your own expertise. These sample experiences also expose your own personal preferences. Boats, they come in all shapes and sizes, appealing to a vast array of different personality types and different people. And what looks important to you on paper doesn't always translate into real life. These sample experiences, they illuminate your priorities. Because when you're building your own boat, you're going to aspire for something more than just a generic hunk of fiberglass that floats. You want something that is specific to your needs and desires. So what are we looking for in a boat? Now, generally, my clients ask about DIY yacht construction for 2 major reasons. Either they're looking for a fully custom design, or they want some major cost savings in their construction. These 2 motivations dictate very different approaches for the do-it-yourself yacht construction. Now, before I discuss those 2 strategies, we really need to take a word here for safety. Avoid sacrificing safety for the sake of budget. The first rule of any yacht construction, accept that even a DIY yacht will be expensive. And that cost is justified when safety becomes an issue. Out at sea, that yacht becomes your life support system. It provides you warmth, food, shelter, transportation, basic flotation. These are all things that you cannot live without. And they're essential capabilities that must always work. Safety is paramount. It sets the minimum price. You have to achieve safety first. Any luxuries beyond that depend on your goals and what you want for your custom yacht. So the first group, clients seeking a custom design. The dream is to obtain a yacht that exactly matches every expectation. Now, these clients frequently seek a naval architect to provide custom designs. Custom engineering is wonderful, but it can cost tens of thousands of dollars to fully engineer a new custom ship. The general heuristic estimate that I give people is that engineering should be around 8% of the cost of construction for the vessel. And that's based upon what you would pay retail price for the vessel. So you can't say, oh, it's only going to cost me $500,000 in materials. No, that vessel would retail for $1 million. And that's a great example there because a $1 million vessel, 8% of that cost is $80,000. So engineering is not cheap. And we can't always go cheaper and cheaper with smaller boat sizes. There's a minimum level where it takes a certain amount of effort just to guarantee safety. So generally, I tell people that for any type of engineering for a custom yacht, full design, you're looking at a cost somewhere between $50,000 to $80,000 is the starting line. For some clients, that cost is justified. But if you're more on the thrifty end, you may want to identify what really matters for you in a custom yacht. Where do you need that engineering, and where can you save on costs? If you're in the end of trying to reduce costs, reduce customization. The biggest thing is engineering a new hull design. That requires the largest cost in terms of engineering. The engineer has to consider the arrangement of the vessel, the weight, the structure, the powering, the resistance. All of those are an extensive set of calculations. And they're all tied together. Instead, let's focus on a more specific customization. Do you really want a completely new hull design? Do you really care about the shape of the hull that much? Or are you just interested in a different interior arrangement? Because a new hull involves concerns for safety. But interior arrangements, that's mostly outfitting, and that rarely requires engineering. So you have to be really careful about thinking about which parts you actually need engineering on, and how can you avoid concerns for safety. Now time for step 3. What will you build the hull out of? What is your material for construction? Common choices are steel, aluminum, and composite / fiberglass. Fiberglass is the most common composite, and there's a whole lot of other exotic choices as well. This is important because your material selection governs the complexity and shape of the hull design. Steel and aluminum are the more conventional hull choices, and they have a lot of advantages. It can be easier to inspect the construction quality with those materials. Local hull stresses are less of a concern on those two, and the material costs are cheaper than fiberglass. At least they were the last time I looked. And one of the reasons I really like this is the quality control for the strength. The strength for these materials largely depends on the metal mill, steel foundry, aluminum foundry, and not your own technique. That's really a big issue. The main concern for metal fabrication lies with weld quality. Welds are easier to inspect than fiberglass. You see, with fiberglass, reliable strength inspections require destructive testing of a sample. You have to actually lay up the hull, cut a piece off, send it off to a lab, and have them stretch it till it breaks. And that has limited usefulness. But there are several non-destructive techniques for weld inspection. From the perspective of construction quality, steel and aluminum are far more reliable. But hold on now, these advantages do come with some drawbacks. Steel and aluminum require far more infrastructure to work with. These are not light materials. They're very heavy. And due to the simple weight of all the members that you're working with, cranes are pretty much essential. And any curvature in the hull, by the way, you need curvature in your hull, is going to require a hydraulic plate bender. That's expensive. And that's only half the truth. Hydraulic plate benders only curve the plate in one direction. The term for this is called developable surfaces. And you can do a lot within that limit. Most fishing trawlers and tugs, other simple ships like that, are built using the limit of developable surfaces. But for more complex hulls that you would see on high-performance vessels, you're going to need non-developable surfaces. That is, you have curvature in two directions on the same plate. That's not easy. It requires advanced machinery, a very skilled welder, or both. For most of us, the idea of metal construction is going to limit us to very simple hull shapes. And don't forget the investments up front for all that machinery and tooling. If you want to build in metal, I hope you already have the infrastructure for it. Well, that didn't sound too good. How about fiberglass? You'd think I'd start praising it. Not really. See, fiberglass, on the other hand, it does allow more advanced construction, more complex shapes. But that also comes with a higher risk for construction quality. Again, it comes back to asking the question of what is the physical strength of that material. With fiberglass, it depends on the skill of the person laying it. Like all composite materials, the final fiberglass structure starts as two separate materials, raw fibers and a resin glue. And the ratio of fiber to resin drastically alters the strength of your final hull. With fiberglass, you control the hull shape and the final strength of the material at the same time during construction. And to really appreciate the scale of variation here, I want you to take a look at the table on your screen. This table shows the relative tensile strength for fiberglass and epoxy. Now those are both in their raw forms, and it also includes steel there for a reference comparison. The strength of your final hull is going to lie somewhere between the extremes of the fiber and the resin. And that can be a huge variability, ranging from well above the capabilities of steel to well under it. Getting the correct balance of fiber to resin is critical for hull strength. But for the average DIYer, getting the correct balance isn't very easy. They're going to probably use hand layup techniques, which are notorious for inconsistent ratios of resin to fiber. Rather than a uniform hull strength, you get a patchwork of weak spots all throughout the hull. Professional shipyards get around this by using advanced techniques and equipment, a process called resin infusion. But without that advanced equipment, the DIY boat builder should plan to compensate for lower build quality. That means overbuilding your hull, putting on extra layers, adding extra weight. Now, there's nothing wrong with that. That's perfectly acceptable. But don't expect lightweight, high-performance hulls when you're having to do overbuilt construction. Step number 4, the time commitment. And this is where we really have to look at the feasibility of construction. It becomes very important when considering your time commitment. Many of my clients drastically underestimate the time and effort required to build a boat. I sympathize. I do this all the time with my own hobbies and projects. So first thing you need to know, whatever your estimate for your commitment, it's almost certainly going to take more time, more effort, more money. I wanted to give people some form of estimating tool here. So I developed a rough heuristic estimate for construction time, and it's just based on the internal volume of the boat. I warn you, it's not the best. It doesn't have a large data set to go from, but it's better than nothing. Construction time was estimated in 2 steps. First, you calculate or estimate the total internal volume of your boat. That's all the internal volume, including all of the hulls and all of the deck houses. Next, you take that internal volume and you multiply it by this ratio. 46 people hours for every cubic meter of internal volume. And that's a rough estimate for your construction time. When we start talking large voyaging yachts, that translates into a lot of working time. Say goodbye to holidays. Look at the table on your screen. Notice how time commitment rapidly expands with the larger yachts. We go from a few years to several decades. The moral of the story, any boat that you construct yourself, it's not going to be a gigantic palace. It's going to probably be small. And most likely, you should stop selecting the boat size based upon your design goals. So the moral of the story, DIY yacht construction requires many compromises to start from scratch. Before making that leap, I'd like you to consider a few alternatives. Option number 1, refitting an old boat. Too often, we overlook the potential of older boats, but these older hulls can hide major finds. Over time, the market value for a boat depreciates. That's just the way the market works. A $1 million boat from 1970 might only cost $100,000 today. The actual depreciation varies depending on the boat. But whatever your depreciation, don't confuse market value with vessel capabilities. Yes, you can expect that for an old hull, most of the machinery and the electronics are going to require updates. But the bones of the boat, the well-maintained fiberglass hull, that can still endure for many more years. Now, of course, it's not all roses. These boats also hold numerous headaches and surprises. They require a careful eye towards the previous ship maintenance and upkeep. Hire a surveyor to carefully examine that boat. Look at all of the details before purchase. Second alternative, salvage boats. Every year, hurricanes and typhoons batter our shores around the world. The ensuing destruction can be tragic, but it also presents an opportunity for you. Those shores, they were full of yachts. Those yachts are now subject to insurance claims. So when the dust settles, The insurance companies are trying to sell these damaged salvage hulls. That's what they're called, is salvage hulls. But what we really mean are damaged boats. Salvage hulls are a whole array of hull conditions. The damage can be anything from mild scrapes all the way up to giant holes in the hull. Consider each salvage hull carefully and get assistance from an expert in yacht brokerage. That's not me, by the way. You're really going to want someone that can help you quickly assess a boat with little information available on it. That's where the opportunity lies. If you are good at repair work and you are willing to take the risk on a boat, then this can be a major find for you. You still have your heart set on building that boat from scratch. No problem. There's a third option, kit boats. See, in conventional hull design, all you're going to get is a set of drawings from the designer. That's it. Kit boats, though, they feature a partnership between the yacht designer and a composite manufacturer. That manufacturer creates the hull of your boat as a series of flat panels that have all been cut out to the exact correct shape. They ship you this giant container full of these individual pieces, and you glue those pieces together. Now, in this case, gluing requires you to join each panel with resin and fiberglass tape. That still requires some pretty major construction, but these boats do avoid many of the concerns with quality control. The manufacturer has already created these panels under ideal circumstances, so you're going to get pretty consistent strength out of that fiberglass. Now, granted, the gluing does still require hand layup of fiberglass, but it's going to be over a much smaller area that layup happens. With smaller surface area, you can safely overbuild each of those joints with less of an impact on your performance. There is a disadvantage to kit boats, though. It's the simplicity of the hull design. In a kit boat, everything starts as a flat plate, and that limits your hull shape. You can't create curved shapes very easily because it's all flat. So don't expect to create a racing hull when you're using a kit boat. So to summarize it all up, really you want to start with picking your priorities. From there, you're going to really decide on your material selection, thinking about how is that going to affect the quality control of the hull. And while you're considering all of those different options, I hope you'll also consider the alternatives. I know it sounds like I'm trying to discourage you, but really, instead I'm trying to ensure you know exactly why you're doing this. DIY construction is not for the faint of heart or for the overly ambitious. Myself, I fall into the overly ambitious category. That's why I don't do it. No matter what, building your own yacht is always going to require more than you anticipated. You need to take time to seriously consider all the hidden costs, extra effort, and all of the alternatives to make things a little easier. Because like I said, I love hearing about people building their own boats. But for me, the best yacht that you can have is the one that you will finish. Thanks very much. I am Nick, the Naval Architect. Oh, filming can be a lot of work. Oh, hi! Speaking of a lot of work, do you find you want to achieve more in the maritime field but need some help with that? Well, you're in luck. DMS is ready to help with engineering services customized to your needs. Check out my website to find the full range of expertise that I can assist you with. Together, we can achieve more. Thanks.